Good morning, students. Today we'll see about a system. We have covered the topic related to signals. We studied the types of signals. Now today we'll see about system. So a system is a thing which gets the input x of t and it produces the output y of t. So we represent the input by x of t and output by y of t. So the y of t can be represented as x of, for example, x of 3 into t. Okay. So x of 3 into t, only for the example we have taken, which is the time shifted version of input. It is called as time shifted version of input. So based on this simple concept, we are going to check the properties of the system. So first property, what we are going to check is whether the given system is causal or non-causal. Okay. First system property. We have studied system as collects the input, produces the output. The output will be the time shifted version of input. It may be any combination, anything related to the input. So we'll check the properties of the system one by one. The first property is causal or non-causal. The first example is y of t equal to x of 3 into t. We need to check whether the given system is causal or non-causal. So before that, we know that causal system is very important point. Causal system is the one whose output depends only on the present and past values of input. Present input and past values of input, then we call the system to be causal. If it depends on future input also, we call that system as non-causal. So this point is very important. Causal system is the one whose output at any time depends on present values of input and past values of input. Output depends on future values of input, then we call that system to be non-causal. We keep this point in mind. We'll move on to the first problem where y of t equal to x of 3 into t. So we need to check for whether the system is causal or non-causal. For example, we'll start with the value of t equal to 0. Any value of t can be taken and we need to check the system property. If t equal to 0, what is the output? Y of 0 equal to x of 0. So for example, if t equal to 1, y of 1 equal to x of 3. You compare these two cases. Output at any time depends on the present value of input. In both the cases, t is 0 here. Okay. But when you compare to t equal to 1, y is equal to 1, y of 1 depends on x of 3. So output at present at t equal to 1 depends on future values of input. Future input. Okay. So this system is non-causal. Present output depends on the future values of input. So the given system is non-causal. Even if one value, for any value of t, you can do it. Even if one value of t, the system is found to be depends on the future value of input, then we call that system to be non-causal. Why we call this as future input? Present value of t is 1, but x of t is 3. T equal to 1, that is the present value, but it becomes 3 here. So that is the future value. Okay, so we call that system to be non-causal. I hope this point is, this sum is clear. We can check it for other values also, but the given system is non-causal. We will move on to the second problem.